Today we're talking about operations on functions. As you can read for yourself right here, you can do a whole lot of things with functions. And so we are going to put this into play. And for the first example, we're going to find f plus g of x. That's how you would say this right here. And all it is adding the two functions together. So another way of looking at this is f of x plus g of x. And so that might make a little more sense to us. So now I'm just going to find f of x up here and see that it's x plus 2, and I'm going to use parentheses like crazy. And then g of x is 3x plus 3x. Now, because I have a plus sign right here, turns out the parentheses don't really mean too much. And so this would say the same thing without the parentheses. I'm just going to combine like terms. Don't assume just because you see parentheses that you're multiplying it. Always look at the operation in the middle. And so I'm just combining like terms. I'm just adding all this together. So this is going to give me 4x plus 2, and I'm done. Well, that was easy, hopefully. Now, f minus g of x, same thing. So it would be f of x minus g of x. So I guess not the same thing, but same procedure. Now we're just talking about subtraction. So I'm just going to go ahead and bring these guys down over here. And I'm going to have x plus 2 minus 3x. And again, I'm just getting those from the actual function itself. And I'm going to combine like terms. So this is equal to negative 2x plus 2. We're going to switch that up a little bit. And the reason I wanted to show you this example is because I want to stress how important parentheses are. And so g of x is 3x minus f of x is a binomial. So if I'm subtracting the entire binomial, I have got to make sure I distribute this negative. Really important. So this is going to be 3x minus x minus 2, which is 2x minus 2. So just be careful with parentheses, especially with subtraction. This is a multiplication sign. Not to be confused with other things that we've talked about this year, which were composition of functions. And so we're going to get to that in just a minute. But this is multiplication. So this is really f of x times, no, try that again, times g of x. And so f of x is x plus 2. Another time parentheses are really important here. G of x is 3x. And so I'm going to distribute this 3x and get 3x squared plus 6x. Done. And so we just want to simplify these as much as possible, meaning no parentheses, and you're combining any like terms as possible. So now we get to more composition of functions. And we talked a little bit about this earlier in the year, but we're going to get a little bit more involved. And so here's a few examples that are functions of something else. So I'll give you a minute just to, actually you can pause it and read that. And moving on. I wonder how many of you actually pause it and read it. I might have like a mini quiz on this tomorrow. All right, so let me just remind you how, oh, you haven't seen this notation yet, I don't think. So this notation right here is f of g of 2. And so we're more familiar with seeing it this way, and I would highly recommend just rewriting it this way. Okay, so this is all about substituting. I'm going to substitute away. I'm going to work from the inside out. So the very first thing I'm going to do is figure out what g of 2 is. Well, g of x is right here. I'm going to do this off to the side. This is my little off to the side notation. So I want to figure that out. G of 2 would actually be 3 times 2. Do you see where I'm getting that from? 2 goes in for x in the g function. And so g of 2 is 6. So I'm just going to substitute. I just found what g of 2 is. It's 6. So I want to find f of 6. Well, now I'm going to look at the f function. And I'm going to, instead of x, I'm going to put 6 wherever I see x. So substituting. So I'm going to put, this is going to be 6 plus 2, which is 8. So f of g of 2 is 8. Going the other way around, let me bring these down here. G of f of 2. Now we're just kind of switching them around, but we're going to get something else. So the very first thing I'm going to do is rewrite this. This is going to be g of f of 2. And so, actually I didn't want to write that equal sign. Oh boy. Okay, so off to the side, I'm going to figure out f of 2 first, because I'm going to work from the inside out. So I'm going to go to my f function, and I'm plugging 2 in everywhere I see x. Sometimes there'll be more than one place where you see x. So this is going to be 2 plus 2, which is 4. So now instead of g of f of 2, I know what f of 2 is. F of 2 is 4. So I want to figure out g of 4. So I'm going to look to the g function and see that g of 4 would be 3 times 4, which is 12. So g of f of 2 is 12. Work from the inside out. Here's one for you to try. I'm going to scoot these functions down for you. You're welcome. Oh, I thought this was different. Never mind. But I want you to try this anyway. So go ahead and read that. Pause it, read it, try it. Moving on. Here are these functions again. But now I don't have a number that I'm plugging in. Now I have an entire function that I'm plugging in. And so, come on. All right, so I'm going to, again, work from the inside out. I want f of h of x. Well, h of x is x squared minus 2. So really, I want f of x squared minus 2, because that's what h of x is. And so I'm going to take that whole thing and plug it into the f function everywhere I see x. Well, it's only one spot. So this is going to be, instead of x, I have x squared minus 2. That's what I'm substituting in. Plus 2. Don't forget about this plus 2 that we have at the end of that. And again, I'm just combining like terms. Minus 2 plus 2, I just end up with x squared. And so that is f of h of x. It's a new function, and the function is x squared. So here's one for you to try, and I'm going to bring this one down. Now this one's a little bit harder, because in this one, well, I'm not going to tell you why it's harder. Just trust me, it's harder. So good luck, try it, and we will talk about this tomorrow.